Hello Java programmers! Guess what? It's June. I hope you're not too bored of all of this. I'm trying to think of things that are a little different and visual and, because there's a lot of code going on. And, well, we'll see. If you're all asleep by now, it's okay, I understand. Now I'm going to talk about objects. This is where it gets real. Okay, so Java is an object-oriented language. And that means that you use these little pieces of functionality called objects. And objects have two categories of things generally. They have variables, and that holds the data. And then they have methods. And that has the sort of skills that the class has, the things that it's able to do. Functionality. Okay, so we have data and functionality. And we're talking about objects here. How that's described by the language itself is, if you say class, then that's an object. This is not a good example of one talking about objects. I'm just using this thing to write stuff so that hopefully it will go into your brain a little easier. But usually an object is kind of like something in the real world, a real world item. And the reason for that is it sort of was, before we had object-oriented languages, we just had procedural languages, and they were a little harder for the human brain to comprehend. So I guess the reason why we have object-oriented languages is it's kind of a natural way for the humans to think. And then there's this other thing that I'm going to be talking about later called encapsulation. You can kind of guess what that means. It's like a capsule. So that's that you can separate things into little capsules so that they don't interfere with each other. And objects help us to do that. Because an object has its own set of data and its own functionality, when you put those two things together, it can be pretty smart. And the idea behind object-oriented programming is you have different objects that are loosely coupled. That means they're not all bound and tied to each other, and they're encapsulated. That means that their data pertains to them and is not exposed to the outside world. And then we can have these really nice architectures and patterns, and sometimes we have these things called design patterns. It's probably a little hard for you guys to comprehend what that means right now because every class we've made has just been one class, but in general we deal with patterns of classes. They're kind of in what you could call an architecture, if I could spell that. It's a good thing I am a programmer and not an architect because, yeah, that would be embarrassing. So we have architecture, and that's kind of like how objects are built together. They're kind of assembled. And in chapters or lessons 8 and 9, we're going to talk about two of my favorite things for that. Well, my favorite really is composition, and that's when you have one object inside another. And then you have them delegating. And then there's all this cool stuff you can do because we have this thing called inheritance. And we have these things called interfaces. And those things, especially interfaces, allow us to write loosely coupled code so we can switch pieces in and out. And well, I just keep going on and on about object-oriented programming. But anyway, it's cool. It's maybe not as cool as some other cooler stuff that's coming out now, like functional programming. But nonetheless, it makes it easier for humans to understand, and it lends itself naturally to encapsulation and loose coupling, which means that your code, when it grows up, or if it goes on past you, you're not the only programmer on there. Someone else might find it to be usable, and then you have been a complete success. All right, so I think that's enough waffle for now, and we're going to start doing a little object. All right, so objects, you can make multiple objects. I'm going to change the name of the class with my refactoring. Oh, I'll slow down and do that a little slower. Okay, so what I did was I pressed my refactoring keys, and my refactoring keys are the Command and the Alt or Option button, and then I did R for rename, and then I'm going to change this into a duck. There you go. Now we have a duck where we had a whole bunch of nothing. Okay, so this is a duck. And remember I was saying that we have data in the class, and then we also have functionality. All right, well, our ducks are interesting, somewhat tasty creatures, but these particular ones, I'm going to give them some things that are different to other ducks. Okay, so, well, I guess every duck's going to have a name, but I'll reflect that in the actual name of it. Let's say that a duck can have a favorite food. And let's say a duck can also have life expectancy. Alright, so we have two pieces of data that are pertaining to this duck. And this duck is also going to have some methods. I'll say that ducks can waddle. I picked ducks because I find these words to be kind of funny. And also we can have them quack. Alright, so this is pretty much my duck. An object is kind of like a template or a stamp, so I'm going to be making different ducks. Each duck is going to have a different favorite food and a different life expectancy. Actually, those may be somewhat related. But anyways, for good practice, and I guess I'm probably going to be talking about this in the next lecture, why we have the data be private, although you might be guessing from what I just talked about, is that we don't necessarily want all of the private stuff related to the duck exposed to the outside world, because, you know, those ducks might be a little shy and they possibly want to hook up with another duck and not have that duck know how long they're going to live. And then usually if these methods are something that's interesting to the outside world, you would put them as public. I'm going to put them as public for now. Let me format that stuff and get rid of this. Okay. Alright, now there's this thing called a constructor, and a constructor is how you create different ducks. And the constructor, ooh, look at that, sets the duck stuff up. This time I'm going to auto-generate because I don't want you focusing too much. Where am I? Source, generate, constructors using fields. Okay, I don't want you focusing too much on what the deal is with this constructor yet, because we're going to be delving into it in the next lecture. I just want, for this lecture, you guys to understand that you can make different ducks, and I'm going to be doing that in a moment. Alright, so we have fields. These things go by different names. So sometimes they're called fields. I don't really call them that. I usually call them member variables. And I call them member variables because they're related to this particular one. Some people call them instance variables. And that's because these things are related to a particular instance. We're going to see in a second how every duck has its own favorite food. That's because that variable is specific to that duck instance. Alright, I'm going to show you how to make some ducks. What should I call a thing that makes ducks? Duck. This is actually a pretty common design pattern, but I'm not going to follow the usual pattern, so I don't want to confuse that. I'll call it duck breeder. Alright, duck breeder. Here is where I'm going to make some ducks. Duck. I'm going to push a little of my agenda right now. Morrissey equals new duck. Alright, I picked Morrissey because he's a vegetarian. And while he's still alive, he's probably going to be alive for a long time. So let's say human years divided by 3 maybe for ducks. So say Marcy lives to be 90. I'm just going to say that duck's going to live to be 30. Okay, so we have the duck Marcy. Now we can also have the duck, what do you call that obnoxious guy that has those restaurants? Rick Bayless. I think that's his name. He just likes all this, a lot of meat and disgusting stuff. Okay, so anyway, he eats frogs. This is not a vegetarian duck. This is a frog-eating duck, and definitely is not going to live as long. I'm going to actually say going to live a good bit less than the vegetarian duck Marcy. Now, to see what I'm doing here, I sort of want to make a method that shows me what's up with my ducks. Alright, so I'm going to make a two-string method. This is an overridden method, and you don't really need to know about that just yet, but I promise I will show it to you later. For now, I'm just going to say favorite. This duck likes to eat favorite food. And will live to be okay. I'm going to give that a whirl. What's wrong with my constructor? Did I mess it up? Save. Okay, well, I just had to save that. And I'm going to say Marcy. I'm just going to do a CISO on Marcy. Ooh. There we go. Marcy, you just get in there. All right. There's a little bit of magic going on here. Here is where it's print out this information about Marcy the duck. But I am a little OCD, so I need a full stop. This duck likes to eat celery and will live to be 30. No, that doesn't go there. Okay, so what's happening, I will make an effort to explain this stuff, is that, well, every method has a two-string, and if you want to make your own specific version of that, you can override this method. I'm just going to take it out so you can see what would have happened if I hadn't put that in there. Now I'm still printing out Marcy. Watch this. Ugh. Now, that is not a very good description of Marcy the duck, so that's why I overrode the two-string method so that now I have the information that I actually care about. It's the specific information about Marcy the duck, Marcy the duck's favorite food, Marcy the duck's life expectancy. So this class duck is a template for making all different kinds of ducks. When I created the duck Marcy, it went over here. Now let's see if I can do this. Okay, yes, I've split my screen. I'm going to try and explain this. I usually use a blackboard. Alright, so what happens when you make the duck Marcy is this celery goes in here as Marcy the duck's favorite food. So that means this is kind of like a method. Because, you know, the way when you have a method and then you match the parameters, this is the same. So this is a constructor, a duck constructor, and celery is going into favorite food, and 90 divided by 3 is going into life expectancy. The next thing that happens is you're in the constructor, and then you're going to do these things. Let's not worry about this super. Actually, we don't even need it. Then the next thing that's going to happen here is it's going to set favorite food, and that's the instance variable favorite food, to celery, and the life expectancy to 30. So that means within this Marcy duck, we have saved forever and ever, unless we want to change it later, we have saved the favorite food to be celery and the life expectancy to be 30. So when we do this two-string method, that's why celery comes out here. Watch what happens if I print out Rick Actually, I think that Rick Bayless is maybe the cool guy, and the other guy is, what is his name? He has those really kind of touristy restaurants around. My friend Lisa hates him. Alright, so Rick, anyway, I'm going to take Marcy off just for a second so that we can watch what happens to Rick. Okay, see? This duck likes to eat frogs but will live to be 20. And as you can see, the only thing that's different between these are these parameters that I put into the constructor, and then my duck class is handling all the rest of it. Okay, so let's move on to the variables, but it's actually kind of really bugging me what this guy is called. He's like Rick Restaurateur. Restaurateur. He makes burgers. It's not Rick Bayless, that's for sure. I know there's one in Playa del Carmen. Sorry, I know that's not super relevant to your Java learning. Anyway, so there's this guy anyway. I'm just going to call him Carnivorous Kevin. They don't have to all be girls. Carla. Now, I'll print them out just so that we can talk a little bit about vegetarianism. Look at that. Celery makes you live longer. Sorry. Okay, now I'm going to put some stuff in here in the waddle method. Waddle. Okay, so I've implemented the method waddle, and then I can do this. I can do Marcy. I can get Marcy to waddle. And then when I run it, it's going to print out the deets of those two guys, and then it's going to print out the waddling. But you know what? Maybe when the duck waddles, that's good exercise. So what I'm going to do is every time we waddle, I'm going to increase the life expectancy of that duck. Okay, so say, if we have carnivorous Carla do some waddling, maybe we can get her to live longer than 20. Let's see. Now, see, she's going to eat till 23. But really, she should start eating more celery and less frogs. But anyways, there you go. So what I'm trying to show you is that the life expectancy has changed for Carla, but it has not changed for Marcy. All right, I'm going to do one more piece of it. I'm going to implement the quack method. Actually, it might be cooler if so we did this in Animal Farm. I think I might get the sounds. That's a quack sound. Quack, quack, quack. Put that in there. This is from the Animal Farm thing. I'm not sure if you guys actually had to do a duck. I hope this works. We're going off script here. Well, to be honest, there's not really any script. It's technically all off script. But don't tell my bosses that. Just kidding. Well, no, I'm not actually just kidding about that, but quack. Sounds. Okay, where the sound file has to come from is sounds quack dot wav. Make embiggen that so you can see what I'm up to over here. Ooh. There's a proper way to do that, but it's kind of hard to talk and code at once. Don't need that sound file. Okay, let's see if we can get the duck to quack. Where's my quack method gone? Oh, it's here. All right. So quack. Marcy. Ha. Okay. Yes. Marcy should be able to quack like some songs or whatever. But I think that's a little bit out of the scope of this lesson. It sounds like a dog. Okay, so am I teaching you anything now, or am I just talking? Let's see. What I wanted you to know is that you can make multiple ducks, and to just condense it down to a few things. I'm just going to comment this out because I want to keep it in the examples. About this instance business. Sometimes you would see this. You would see me writing something like this. So this is a kind of a typical thing that you'll see in the recipes that are coming. And I want you to hopefully get familiar with this terminology. Create an instance of a duck. All right, to create an instance of a duck, it's kind of like a variable. So you remember the way a variable has a type, and then it has a name, and then you can set it equal to a value. Making instances is pretty much the same, except the type is different. So in this case, instead of a string or an int, the type is going to be duck. We're instantiating a duck, just call that Daffy. This is a small d because usually instances have small letters. And then to instantiate or to create an instance, you use this keyword new. This new calls that constructor. I'm going to be talking more about constructors, so don't be too confused about these things because it's hard. But anyway, so I'm making my duck, and just like a method, I've got to put those two things in. So if I was super lazy, I could just put in a string, and then I could just put in an int. And technically, I have created an instance of a duck called Daffy. A pretty boring one. An anorexic one, doesn't like any food and, well, is already dead. Okay, so got Daffy, so then I would have done that, and that would have created my Daffy. And then I would get Daffy to quack. I'm just doing this because I like the sound. Well, I'm also doing it because I want you guys to get to understand this pattern. So when I want to use this quack method, it's part of the duck class. It is a non-static method, so I need to create an instance first. And I think that's it. I think that's everything for now. There are some exercises for y'all. That should be over there. The exercises that I'd like you to do are called Harry Potter and Cat. All right, let's talk soon. Bye.